Hello everyone and welcome back to our Python data science workshop. I'm Chi and today we're going to talk about something pretty important in Python, that is control flow statement. So what does control flow mean? It refers to the order in which our code is being executed in a programming language. And in Python, the control flow is usually regulated by conditional statements, loops, and functions. And in today, we're going to demonstrate the example of them. So in this session, what we're going to cover is first, we're going to talk about if statements and for loops and while loops, as well as how we can escape from a loop. So let's begin by first talking about conditionals. In the previous session, we've learned that Boolean operators will assess the condition we specify and return either true or false, these two values. And now we're going to see how we can use this in the actual code to make decisions by using the if statements. So here, let's look at this example. So first, we're trying to define a variable called x, and now we're trying to create an if statement. So we first start by putting the keyword if, and then we need to put a condition. And in this case, what the if statement is going to access is if x is more than 0. And then you need to end with a colon. This is pretty important because that's the syntax of Python. And then you're going to realize that the next line is intended. And this creates what we call a code block. So if the condition is true, Python will execute the intended code block. That in this case, it will be print x is a positive number. But if it's a false, then Python will just skip it and move on. So now let's try to see this example. As we can see that x is 4 in this case, and we know that 4 is more than 0, so it will run this print function and gonna print x is a positive number. So this example just showed you how you can use if statement to do some very basic conditional assessment. And similarly, you can also modify and see what will happen. So in this case, for example, if we change x into -1, and because the condition of x more than 0 is not met, so what Python will do is that it's just going to skip, and you can see that there's no output from this code. You can do more than just one single if statement, and sometimes we want to do one thing if a condition is true and something else if it's false, and that's where the else will come in. In this case, we add another condition after if using the else, and this we're going to print y is not a positive number. So now our code will always print something either telling us y is positive or that it is not positive. If we print this, as you can see that because y is negative, so code under the if statement will not be run, but instead the else function, we're going to print that y is not a positive number. And sometimes we may need to check multiple conditions, and that is where else if come in. So we can have as many as else if statements as we need, and Python we're going to check each condition in order and execute the code block for the first true condition it finds. So let's break this down. Here again, we just add a new condition where if y is equal to 0, then it will print y equal to 0. If we change y into 0, and you can see that it will print y equal to 0. So you can add as much as if statement that you want Python to access. Now let's look at a more practical example. Imagine that we are writing a program to help with baking pies, and we want it to tell us how many pitches we need according to different pie size. In this example, we have the number of pitches as the default input as bad, and then we have the pie size as 10. So in this case, what this following condition is going to do is that it's going to take the input pie size and trying to access or trying to calculate how many pitches that you're going to need to make for the exact pie size that you specify. So for example, if we have 8-inch side pies, then we might need 6 pitches and so on. And so let's see how this will work. Remember now the input default is that pie size is 10. And we can see that it's telling us that we're going to need 9 pitches. And if we change this, for example, into 12, then it's going to tell us that we need 11 pages. But if we put something that's not considered as a valid pie size, in this case, the valid pie size is 8, 10, and 12. Let's say if we put a 7, and then this will gonna tell you that this is not a valid pie size, and it's gonna also tell us, so there's another function that follows this if statement. So, and the input is that if the number of pitches equals to bad, then it will tell us what kind of input for pie size is accepted in this case. And it's going to tell us we need either 8, 10, or 12 inches in the pen. So now I would suggest you that in your own practice, you can try to change the pie size. So now let's move on. In Python, there are also several operators that can be used together with if statements to evaluate more complex conditions. So the first one that we're going to talk about is the in operator. It allows us to check if an item exists within a collection, like a list. And in this code example, so now we are first defining a list of different fruits. You can see that we have a lot of different fruits: apple, kiwi, pear, tangerine. And now let's just first try to see. Yeah, so now we got a list of different fruits. And then in this code example, you can see that here we're defining first the selected fruit. In this case, it's kiwi. And then we just put an in statement. So if the selected fruit is actually in the fruit list that we just identified, if it fulfills this condition, Python will print the fruit is in the fruit list. Else it will say that it's not in the fruit list. So it is really a quick and readable way to perform this kind of check. If we print this, as we know that kiwi is in our list, and then we can see that Python is telling us, yes, kiwi is in the fruit list we just defined. Now I would suggest you to also pause the video and then try to change the input for the selected fruits, or just try to name a fruit that you like but it's not on this list and see the change of the output. So moving on, sometimes we may need multiple conditions to all be true, and then that's where the AND operators come in handy. Now let's look at a more complex example. So in this case, we have actually another different fruit list that's categorized by if the fruit is tropical or seasonal. And then we have a fruit that is mango. And then what this is going to do is that we're going to check if the fruit that's if it's in both the tropical and in the seasonal list. And then what this code is going to tell us is that if one specific fruit is both tropical or seasonal, or it's either a tropical or seasonal, or it's not categorized in this case as tropical or seasonal. So what the and condition gonna do is that it's gonna assess if this item is in the list of these two. And we can see that in this case, mango is only showing up as is only included in the tropical list, but not on the seasonal list. So that's why it was gonna only tell us that mango is a tropical fruit. But however, as we know that kiwi is both seasonal and tropical, and if we change this, for example, to kiwi, then we're gonna see that Python will tell us that kiwi is both a tropical and seasonal fruit. The next one is the OR operator, and it is used to write an if statement where one of the multiple conditions must be met. Now we have acidic fruit list and also a sweet fruit list. If the fruit is either acid or sweet, then it will be recognized as flavorful fruit. But if it's not in the acid or sweet list, but still, however, in our fruit list that we identified before, then it will be considered as a neutral flavor fruit. However, if none of the condition has been met, then in this case, we're just gonna identify as a fruit item that is not in our fruit list. In this example, if we put orange And then we can see that orange is in the acidic list, so it's recognized as a flavorful fruit. We can also change this to, for example, fig. And since we know that fig is in the sweet fruit list, we will know that it's still considered as a flavorful fruit. So as long as if it's in the acidic or sweet fruit list, it will be considered as a flavorful fruit. The or operator again is used when we want at least one of the multiple conditions to be true. Now moving on, you can also nest the if statement together to perform more complicated operations. And nested if statements are exactly what they sound like. So it's an if statement inside another if statement. And this will allow us to check for multiple conditions in a hierarchical manner. So now let's still continue with our fruit example. So in this example, we have two new category of fruit. So the first one is juicy fruit, the second one is crisp fruit. And then we have also our fruit input. In this case, it's apple. So now let's look at this example. So first, in this if statement, we're going to check if the fruit is in our main fruit list. If it is, then we will check if the fruit, if it's in juicy or in the crisp fruit list. And then based on this nested condition, we're gonna print different messages. So if the fruit is not in our fruit list, it will skip all this intended code, as we said before, and directly move to the else statement, and they're gonna print this is not in our fruit list. However, if the fruit is on the list, then it will go through the second if statement, and then to check if it's in juicy or in the crisp statement. Now let's first try with apple. And we can see that apple is in the crisp list. So it's going to print that apple has a distinct texture. If now we put, for example, fig in this case, and we know that it's still in our fruit list, but it's not being classified as either juicy or crisp, this will print fig has a standard texture. But however, if we put something that is not on the fruit list, for example, coconut, then we're gonna see that yes, coconut, sorry for the typo, coconut is not in the fruit list. Now let's look at a slightly more complex example involving making peach pies. And what this script does is that it's gonna tell us if we have enough peaches for making a pie. And in this case, first it will check if we have any peaches at all, and if not, it's just gonna tell us no peaches available. Maybe we can buy some. And then if we have peaches that is more than zero, but however less than five, then it's gonna tell us that we have a few peaches, but not enough for a pie, and so on. So based on different number of peaches, it will suggest different actions. And now I would suggest you to try changing the pitches number to different values and see how the output changes each time. And the final note is that while the nested if statements is intuitive to understand and is quite powerful as we can create more complex decision trees and check conditions in a specific order, however, you must be careful because sometimes too many nested if statements can make you hard to read and maintain, and also it's less efficient for Python to run. So if you find yourself with many levels of nesting, it might be better to consider restructuring your code or using other constructs functions. And later in this tutorial, we're gonna introduce you how we can avoid to have too many levels of nested if statements. Now that we have covered conditionals, let's move on to another fundamental concept in Python, loops. So loops allow us to repeat actions multiple times without writing the same code over and over. So it really can improve the efficiency. And the most common type of loop in Python is the for loop. It's used to iterate through any objects that is capable of returning its members one at a time. And in Python, we call this an iterable object. And here is the basic syntax of a for loop. So the iterator is a temporary variable that stores each value from the iterable object as the loop progresses. And then the iterable is the object being looped over. It can be a list, a string, and then this intended code block after the column is executed for each value in the iterable. So in this example, this will print the number 1, 2, 3, and 4. The range for function creates an iterable of a list from 0 to 3. And then our loop will print each of these value plus 1. So if we exit this, you can see that 1, 2, 3, 4 is being printed. And we can also use for loops to iterate through list. Recall that the fruit list we made before. By using this for loop, we can print each element in the fruit list. And you can see that what this will do is that it will go through each item in the fruit list and then print the fruit. So this will print all the items in the fruit list. And just a final note, the name of the iterators. So the iterators acts like a placeholder that takes on the value of each item in the iterable one at a time. So for example, if you, in this case, we are looping through a list of fruits, right? So we will use fruit as our iterator name. And this will make our code more readable and self-explanatory. And also before you can see that I is also a common iterator name when you are just counting. But for most other cases, a descriptive name would help to clarify what our loop is doing. So Python also provides some really useful built-in functions that works great with loops. And now let's look at some example of them. So the first is the enumerate function. It is used when you need both an index and also the value from an iterable. It is especially useful when we need to keep track of the position of the items in a list. So let's see an example. So here we're first defining a list of popular drinks, and we have coffee, tea, soda, juice, and water. And now this example demonstrates the use of the enumerate function in a for loop. Here is what's happening. So first we start with a list of beverages, and then the enumerate function is used to loop through this list. It will return two values for each item. First is an index, and that's in this case is specified by the I. And second is the actual value of the item. In the loop, I represents the index and beverage represents the current item from the list. And we're gonna add 1 to create a more understandable rank. As we know, we typically start counting at 1, not 0. And finally, we're gonna print, in this case, we're using the formatted string that include both the rank and also the beverage name. So this is going to print the rank and also the beverage name. So the first most popular drinks is coffee, followed by tea, soda, and juice. And we can see here we also have their rank. Secondly, we have zip function. So the zip function is used to iterate through multiple lists at the same time. It's really handy when you have related data but in separate lists. And here in this example, again, we have our drink list and also have a temperature list and their cost. So the zip function would pair up all the elements from each list and creating what we call a tuple. And in each iteration of the loop, we're going to unpack these tuples into 3 variables. That is beverage, temperature, and cost. And then we'll just use, again, the formatted string function to print the 3 items all at the same time. So if you run this code, we can see that it's taking coffee from the drink list and also the temperature and then also the typical cost per serving. And by using the zip function, it allows us to work with related data from multiple lists in just a single loop, which is more efficient and readable than using separate loops or indexing. And finally, if you want to see how the zip objects look like, you can print them and then this will return you can see that there are tuples, but each of the elements from the separate list is packed in a single parenthesis. So finally, you can even combine the enumerate and zip function if you need the index as well. So in this case, we're adding the index again, but we're gonna use the enumerate to wrap the zipped object. So this case, we're trying to also include the rank. And this was going to tell us both the rank of drink as well as its temperature and also the cost. So some final important notes. The first is that when using zip function, you need to make sure your lists are of equal length, or you'll only iterate through as many items as are in the shortest list. Second, the variable I is commonly used as a counter or enumerator. For clarity, try to use more descriptive name for other types of iterators. And lastly, remember that indentation is very crucial in Python, especially if you're working with if or for statements. And all the codes that should be executed in each iteration of the loop needs to be indented. And just like if statements, you can also nest the for loops to perform an operation multiple times for each iterators in the overall loop. So let's look at this example. So in this example, the outer loop will go through each fruit in our fruit list. And for each fruit, we set up a vowel counter, and then we're gonna start an inner loop that will go through each letters in the fruit's name. And if the letter is a vowel, we're gonna increment our counter. And after checking all the letters, we will print the fruit name and its vowel count. And you can see that in this case, the nested structure allows us to perform a detailed operation, which is counting vowels on each items in our main list. And nested for loops can be very powerful, but also remember that they could be very computationally expensive if you are dealing with large data set. So we need to use them wisely. Okay, second, we also have while loops. So while loops are another powerful tool in Python. They repeatedly execute a block of code as long as a given condition is true. Let's see the example. So first, we start with x equal to 0, and then the while loop will check if x fulfilled a condition, in this case, x less than 4. And if it is, it will start running the indented code block. And in this case, we're trying to increment the value of x by 1 and also print its value. So this loop will print the number 1, 2, 3, and 4, but it will stop when x is no longer less than 4. So if we print this, we can see that once x reaches 4, the while condition is not met, so it will be terminated. One particular use for cases of while loop is for handling user input, because they allow us to keep prompting the user until we get the input we want. So here is an example. So the loop is asking us the question, what is the answer to life, the universe, and everything? And in this case, we define this answer as 42. But however, if we put something, say 7, it will just keep prompting this user task and until we put the correct answer. In this case it's 42, and then this while loop will be stopped. And one thing to note that is the while loop can be infinite, so they should be used very carefully. So imagine if instead of x equals to x plus 1 in this example, if we change it, for example, to x equals to x minus 1, on each of the while loop, the value of x will decrease. So the condition of x minus x less than 4 will always be true, and this loop will never stop because the condition can never be met. And now we're going to tell you how we can escape from the loops, because sometimes we may need more control on our loops. So to terminate a loop iteration or the loop itself, Python provides two key statements for this. That is break and continue. So first, let's look at the break statement. So the break statement allows us to exit a loop entirely regardless of the loop condition. It is useful when we have achieved what we need and don't need to continue the loop. So here, so you can see that if the condition has been met and we put a break, and this break will just take us outside of this loop. Let's look at this example. So we start with while true, which would normally run forever. And then we ask the user for input, your answer. And if the input is the number 42, we're going to print that you have solved the ultimate question. And for any other input, we're going to ask again. If we put, for example, 8, as we know that 8 is not equal to 42, so the break statement in this case will not be activated, so we cannot run away from this while loop. But however, if we put 42, you can see that this while loop has been terminated and we have solved the ultimate question. Second is the continue statement. So the continue statement is used to skip the rest of the current iteration and move on to the next one. The difference is that the break statement is going to take you outside of the loop iteration, but the iteration will still continue if there are more objects to iterate through on the loop. So it is useful when we want to skip over certain values in our loop. And let's look at this example. In this case, you can see that we have a list of mixed data types. We have numbers and we also have strings. If we encounter a string and then we use the continue to skip to the next iteration. But however, if it's a number, then we're going to print the value divided by 2. This will allow us to only process the numerical values and skipping over the strings. And you can see that only the numerical has been calculated and the result has been printed. All right, now let's wrap up our session with a really cool Python feature that is list comprehensions. And these are a very powerful and concise way to create lists in Python. So let's start with a very simple example. Say we want to create a list of square from 0 to 10, and we can do it with a traditional for loop like this. So in this case, for x from range 11, and we just calculate the squares and then append them into the empty list. And this will give us the result. But with a list comprehension, we can do this in just one line of code. Here, squares equal to square brackets and then x to the power of 2 for x in range 11 is the iteration over the range from 0 to 10. And you can see that this is just one line of code. It's way more efficient than using a for loop. And you can see that both the methods produce the same result, but the list comprehension is more concise and often faster. And we can make our list comprehension even more powerful by adding conditions. For example, if we want to create a list of all even numbers from 0 to 100, you can just add an if statement after the for statement that specify the condition that x needs to be even. And you can see that this is printing only the even numbers from the range of 0 to 100. So that's all for today. And I would suggest you to